So the question here is find the Fourier transform of the following. So the question is, so they are given to find the Fourier transform of del of n minus k. So you know the formula for discrete type Fourier transform, because here it is n, so you have to take the discrete time Fourier transform. The formula for discrete time Fourier transform is x of e power j omega is equal to summation n is equal to minus infinity to infinity del of n minus k e power minus j omega m. So in order to make the del del of 0, you have to substitute the n value. So the n value must be equal to k. Okay, if I substitute n is equal to k, this becomes summation n is equal to minus infinity to infinity. So since for n for del, if I substitute n is equal to so here if I substitute n is equal to k, this becomes 0, right? So if this is become 0, del of 0 value is 1. Okay, for the rest of the value, of del of something is 0. So if only for n is equal to k, you will get the value. So the answer is e power minus j omega k is the answer. Okay, so the second question is u of n minus k. So if that is the case, x of e power j omega, that is equal to summation n is equal to minus infinity to infinity u of n minus k e power minus j omega m. So u of something is 1. So if you see u of n is equal to 1 for n is greater than or equal to 0. So in order to make this one is equal to 0, okay, so you have to substitute the n value is equal to k. So I can write n is equal to k to infinity, right, e power minus j omega n. So if I substitute n is equal to k, this becomes u of 0. So u of 0 is 1. Okay, so the 1 into e power minus j omega n. So for the rest of the values, so if the multiples of k, you will get the answer as 1. So you have to substitute like this only. So if you see, if I expand this one, so it becomes e power minus j omega k plus e power minus j omega k plus 1, right, plus e power minus j omega k plus 2, right, plus up to e power minus j omega infinity, right. So here if I take e power minus j omega common, e power minus j omega k common, I will get 1 plus e power minus j omega plus e power minus 2 j omega plus up to e power minus j omega plus k, plus k. So e power j omega infinity. Okay. So this I can write it as e power minus j omega k. The formula for this one is 1 divided by 1 minus e power minus j omega. That is a formula. Okay. So the answer of this one is e power minus j omega k divided by 1 minus e power minus j omega. Okay. So let us come to another problem. Suppose they have given the x of n value. X of n value is nothing but 2, minus 2, 1 and 1. Okay, so what is the value of e power j omega? So e power j omega is equal to, so here the n value is 0, then it is 2. So you know the formula, right? N is equal to, so here it starts from 0. So 0 to 0, 1, 2, 3. 0 to 3 x of n e power minus j omega n. So if I substitute, I will get x of 0 into e power 0 is 1 plus x of 1 into e power minus j omega plus x of 2 into e power minus 2j omega plus x of 3 into e power minus 3j omega. So what is the value of x of 0? It is 2 minus 2 e power minus j omega plus e power minus 2j omega plus e power minus 3j omega. So this is a value. Okay. Suppose they have given fourth problem. X of n is equal to 0.5 of 5 power n un plus 2 power minus n u of minus n minus 1. So what will be the value of e power j omega? That is equal to, you know the formula, right? So for x of n, you have to substitute 0.5 power n u of n e power minus j omega n. So this is one, n is equal to minus infinity to infinity plus summation n is equal to minus infinity to infinity 2 power minus n u of minus n minus 1 e power minus j omega n. Right. So since u of n is greater than or equal to, if n value is greater than or equal to 0 to infinity, it becomes 1. So I want to substitute n is equal to 0 to infinity 0.5 n e power minus j omega n plus. So here if I want to substitute, want to make this one as 0, I have to substitute n is equal to minus 1. So that is equal to minus 1 to infinity, right? So if I substitute minus 2, this becomes 2 minus 1 is 1. So if I substitute 2, it will goes to infinity. So it is from n is equal to minus infinity to minus 1 to minus infinity. Okay. 2 power minus n e power minus j omega n. Okay. So this I can write it as the formula for this one, right? N is equal to 0 to infinity 0.5 e power minus j omega n, right? Plus summation. So in order to make this one as 1, you have to change the n is equal to minus 1 minus n. So if that is the case, I can change this one into e power j omega of n. Okay. So this I can write it as 1 divided by 1 minus e power 0.5 e power minus j omega. So that is a formula for this one. Plus since it is starting from 1, you have to write the numerator term as 2 into e power j omega divided by 1 minus 2 into e power j omega. Okay. So if you want, you can minimize this one. Otherwise, you can keep it like as it is. Okay. So in the above equation, you have to write. So you should not write from minus 1 to minus infinity. You have to write it as minus infinity to minus 1. So that is a change. So after that, if I substitute n is equal to minus n, you will get n is equal to 1 to infinity. Okay. So rest is correct. So the next problem is they are asked to find the f of that is Fourier transform of y of n, that is equal to y of e power j omega, right? So if I want to find f of n into x of n, n into x of n, the formula is j into d of x of e power j omega by d omega, right? So what is f of n n square x of n square of x of n is nothing but j into d of x of e power j omega by d omega into j into d of x of e power j omega divided by d omega, right? So that is equal to minus of d square x of e power j omega by d omega. So suppose the question is f of n minus 1 square x of n. Okay, so that is nothing but I can write it as f of n square minus 2n minus 1 of x of n. Okay, so this I can write it as f of n square x of n, right, minus f of, right, 2n into x of n, right, minus plus, this is plus, right, plus f of x of n, right. So what is n square of x of n? N square of x of n is nothing but minus d square x of e power j omega by d omega minus, from this equation, minus f into, sorry, minus 2 into x of n. So if I multiply this one by 2, okay, I will get minus 2j d of x of e power j omega by d omega plus f of x of n is something but x of e power j omega, right. So this is the Fourier transform of the equation. Okay. If suppose they are given, they are given x of n is equal to, there's a next problem, 1 by 2 of n u of n. They are asked to plot the magnitude and phase. Okay, so you know the formula, right? E power j omega is equal to summation n is equal to minus infinity to infinity x of n e power minus j omega n. So here, since it is u of n, I have to substitute from n is equal to 0 to infinity 1 by 2 of n, 1 by 2 of n e power minus j omega n, right. So this is equal to summation n is equal to 0 to infinity 1 by 2 e power minus j omega of n, right. So the formula for this one is 1 divided by 1 minus 1 by 2 e power minus j omega. Okay, so this if I want to find the, this is nothing but x of e power j omega. So if I want to find the magnitude, so magnitude of e power j omega, so this I can write it as 1 divided by, so usually this I can write it as 1 divided by 1 minus 0.5. This is cos of omega minus j sin omega, right, j sin omega. So even if I split this one, I can write it as 1 divided 1 minus 0.5 cos omega plus j 0.5 sin omega, right. So if I take the magnitude 1 minus 0.5 cos omega the whole square plus 0.5 sin omega the whole square, root of this value, right. So this is your magnitude value. So this I can further 1 minus cos omega, right, cos omega, I will get plus 0.25 cos square omega, right, plus 0.25 sin square omega, 8. So here I can write it as 1 divided by 1 minus cos omega. So if I take 0.25 common, I will get cos square omega plus sin square omega, that is nothing but 1. So we will get 1 by root of 1.25 minus cos omega. That is your answer. That is your magnitude. So if you want to find the phase of this one, okay. So since this is my question, right? X of e power j omega is equal to 1 divided by 1 minus 0.5 cos omega plus j 0.5 sin omega. So that is equal to, since it is in the denominator, you have to use minus tan inverse of the j value. J value is 0.5 sin omega, 0.5 sin omega plus that real term. The real term value is 1 minus 0.5 cos omega. Okay. So in the both equation, if you substitute the value for omega from 0 to or minus pi to pi. So if you substitute the value of omega, it is usually ranging from minus pi to pi. So you can plot the values for the magnitude and the phase.